Okay, Algebra 2s, let's look at using equations to solve word problems. So this is one of my all-time favorite memes right here. How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. It's just one of my favorite ways that people describe their problems with math, because that's funny. And a lot of folks feel that way because they've never been given a strategy, a procedure, a method for dealing with the word problems. So what we're going to do today is we're going to look at 4 different types of word problems. They're all set up and ready to go in this flip chart. I'm also kind of going insane sitting in the quiet making these videos, so I'm going to start playing some music in the background. I'm going to go ahead and play the first album from Phoenix while I'm actually doing this time. Let's see if you can make sure you can hear it. Okay, it's not too loud, just in the background. Let's get started. Okay, transportation problems. Transportation problems involve trains or cars or airplanes, and they're flying or driving or moving in opposite directions most of the time. When we do these problems, we're going to draw a diagram or a map, and we're going to use the equation rate times time equals distance. You'll see this with Miss Gardner this year in physical science quite a bit. Let's give it a shot. Mike and Adam left a bus terminal at the same time and traveled in opposite directions. So we're going to make a bus terminal. Mike's bus was in heavy traffic, and so as a result it moved quite a bit slower than Adam's bus. In fact, 20 miles per hour slower than Adam's bus. After 3 hours, their buses were 270 miles apart. So this is 270 miles. Alright. We're going to use rate times time equals distance, and I like to make a little table for that. Rate times time is equal to distance. Here's my little table. And on the top, we're going to have Mike's car. And on the bottom, we're going to have Adam's car. I'm sorry, they're not cars, they're buses. Mike's bus and Adam's bus. The time is the same for each one. It's 3. So 3 and 3. Alright, they told us that Mike went slower than Adam. Let's make Adam our variable r for rate. Oop. Forgot to switch back to the pen. R for rate. Mike is going slower. How much slower? 20 miles per hour slower. So his rate is r minus 20. Now we don't know the individual distances that they're traveling. We know Mike is not going as far as Adam. But we do know is that the total distance that the two of them travel is 270 miles. So in a problem like this, what we're going to do is we're going to get an expression for the distance that Mike traveled and an expression that the distance for Adam traveled. We're going to add them together and set them equal to 270 miles. Alright, so in order to find distance, it's rate times time. So the rate, which is r minus 20, times 3. And for the second person, for Adam, it's the rate, which is r times 3. So the equation is going to be Mike's distance and Adam's distance for a total of 270 miles. So that's the equation you're going to solve. Go ahead and go through and solve that. I'll pause it and do the same. So pause your video, solve it, see if you have a speed for me that each of the guys was traveling in their buses when you're done. Alright, and there we have it, r equals 55, which means Adam was traveling at a speed of 55 miles per hour. And Mike? Well, Mike was traveling at a speed 20 miles slower than that per hour, so 35 miles per hour. Stinks for Mike. Going to take a long time to get where he's going. Alright, that's a transportation problem. So draw your picture, use your r times t equals d, and of course, we will work together with any questions and confusion that you have. Next. Age word problems. In age word problems, I want you to name the youngest person with the variable, preferably his or her age in the present, in the present day. Use your variable that you used for the youngest person to describe the value of the other ages in the problem. Okay, so we're only dealing with one variable equations right now, nothing more. Example 2, okay, here's our age word problem. Abigail is 6 years older than Ian. 6 years ago, she was twice as old as he. What is her age now? All right, so let's first talk about what our unknowns are. We've got 4 unknowns. We've got Abigail's age now. We've got Ian's age now. We've got Abigail's age 6 years ago. And we've got Ian's age 6 years ago. Okay? All right, Abigail's age now, she's not the younger one, she's the older one. We're going to name Ian A for his age now. Abigail is 6 years older than Ian, so she's A plus 6. Abigail's age 6 years ago, well, take her age now and subtract 6 from it. So 6 years ago, Abigail was the same age as Ian is now. And for Ian's age 6 years ago, take his current age and subtract 6. All right? It clearly states in the problem, 6 years ago, she was twice as old as he. So Abigail's age 6 years ago, which is the A plus 6, that's a 6 there, minus 6, so just A. So Abigail's age 6 years ago was, so that's your equal sign, twice as old as he. What's he? Well, that's Ian's age 6 years ago. So there's your equation for this one. Go ahead and pause it and solve that one and see if you can tell me how old Abigail is. And there you have it. A equals 12. Now, A, remember, was Ian's age now. So Abigail's age now would be 12 plus 6. Abigail's 18. Fabulous. Next type of problem. Plane geometry problems, specifically rectangles, and that's where we're going to start for now for the geometry problems. You might have done some problems like this last year, I'm not sure. It's a geometry problem. That means there's a picture that can be drawn, so draw a picture. Label the shorter side with a rectangle with the variable, and then name the other side in terms of that shorter side. That way you're building on the variable instead of taking away from it. You won't have to deal with subtraction and division, rather you'll be dealing with addition and multiplication. Okay, example 3. The length of a rectangle is 5 centimeters greater than twice the width. So I'm going to draw my rectangle. The length is 5 centimeters greater than twice the width. The perimeter is 28 centimeters. Find the dimensions. Oh, hold on. I had to fix the capitalization error. Find wasn't capitalized. Anyway, find the dimensions of the rectangle. Okay, so we have, didn't mean to move that, sorry. We have the width, which we're going to call W on each side. The length is 5 centimeters greater than twice the width. So twice the width would be 2 times W. And that's this side as well. To find the perimeter, we've got each side, or 2 times each of the sides. Okay, so all 4 sides are 2 times each of the sides. So you could go 2 times 2W plus 5 plus 2 times W equals 28. And that's what you're going to solve. Remember, once you find the width, you find the length. So pause it, try it, then come back and take a look at the work. Did you get the width is 3? Well, the width is 3. Now when it says find the dimensions, though, that means we need to be finding both. So we have a width of 3. So width equals 3. All right, and the length would be 2 times that width plus 5, which is 6 plus 5. So the length is 11. Fabulous. One more type of problem, and that'll be it for tonight. Consecutive integer problems. All right, we've done these before. We're going to step it up, and instead of just adding the consecutive integers and having a total, we're going to be manipulating the consecutive integers. So name the smallest with the variable. Again, it's easier to name the smallest and build on it than it is to name the larger and cut it down. Name the others by building on that variable, as we said. All right, there are 3 consecutive even integers, such that twice the first is 20 more than the second. Find the integers. So 3 consecutive even integers. So let's start with naming them. We'll name the first one x, so the first integer. Well, what's the next even number after x? If x is an even number, how do I get the next even? Yeah, I add 2. All right, the next, or let's not say next, let's say second. Oh, why won't that go back? Erase, erase, erase. Okay. Second integer. And the third one would be x plus 4. So we add 2 or 4 when we're dealing with consecutive odd. And actually, when you're dealing with consecutive even, when you deal with consecutive even, definitely. And actually also when you deal with consecutive odd, because odd numbers, remember, are 2 apart. Okay, twice the first. Twice the first. Let's do that first. Twice the first. So twice the first of the integers, so 2x, is your equal sign, 20 more than the second. And the second would be x plus 2. So twice the first is 20 more than the second. Find me those 3 integers, please. Did you get 22 for the first one? Because I did. So that makes them 22, 24, and 26. So we're going to be working on a problem set that will involve a whole bunch of stuff like this. And I hope that you have your mind open to working on these equations. And if you need my help, of course you know I will help you. So thank you so much for watching, and I will see you guys in class.